Hello everyone, welcome to the class on basics of electrical engineering. And before moving on to the video, we can just go through the course outcomes of our subject. And you can see that for this particular subject, we are having two course outcomes. And in this video, we are going to just see a topic that is dealing with our course outcome 1. Now, in this particular lecture series, we are going to study the mesh matrix method of the module 1. Now, the mesh matrix method is similar to the mesh method which we have already studied. We already know how to solve problems using the mesh method, and this is a similar method, only we are going to solve the circuit in a matrix form. Now, this is a circuit, a problem. We can just go directly onto the problem. You have to calculate the current drawn by from the source in the network using mesh matrix method. So, in mesh matrix method, it's a simple method. The first few steps are similar to that of the mesh analysis. So the first step in mesh analysis is to identify the number of meshes. And in this particular circuit, you can see that we are having two meshes. Okay, in this particular circuit, you are having two meshes, and I'm going to assign the current directions. Here I'm going to mark a clockwise current, that is I1. And here I am going to mark a clockwise current I2. So we have marked the two mesh currents I1 and I2. Now in this particular circuit, since there are only two meshes, our matrix form will be a simple form. Okay, so the mesh matrix method, the first thing that you need to know is that we are converting our mesh equations into a matrix form. Since there are only two meshes, we have a square matrix which is a 2 by 2 matrix. Okay, this is going to be a 2 by 2 matrix. Okay, it is depending on the number of meshes, and this is going to be your resistance mesh, and the elements will be R11, R12, R21 and R22. So I have just given the names in the normal mesh naming method. And this will be multiplied with a current matrix, which is a column matrix, and you can see the elements are I1 and I2. Okay, so R into I is equal to V. That is our Ohm's law, right? So V, you are having a voltage matrix V1 and V2. Okay, so I1 and I2 are our mesh currents, I1 and I2, and we have to find out I1 and you have to find out I2. That is our aim, and finally we can see what they have asked in the problem. Okay, so we need to know how to fill this particular matrix. So as I had already mentioned, I1 and I2 are the values that you need to find out. So you don't know I1 and I2, and I am writing it as it is. Okay, now next we are going to fill the voltage matrix. It is a simple matrix. Okay, so the value V1 is corresponding to the algebraic sum of voltage sources present in mesh 1. Algebraic sum of voltage sources present in mesh 1. So you can see there are two voltage sources present in the mesh 1. Okay, so how can you write the value of V1? Okay, V1, now in the normal mesh method, what you usually do, if you are having a current I1 flowing like this, what you're going to do, you can see over here, you will take for plus 7 volt, you will take it from negative to positive. So you will consider it as plus 7. Then you are having the current is going like this, and you can see it is going from plus to minus. So the 6 volt will be minus. So here you can see that V1, I'll just write it over here, V1 is equal to, what did we say over here? Plus 7, and you can see it is going, see, plus 7, and when it is going like this, it is going to be minus 6. So V1 will be equal to plus 7 minus 6, and plus 7 minus 6 will be 1 volt. So the value of V1 is 1. Similarly, V2 is going to correspond to the value of algebraic sum of voltage sources present in your mesh 2. So how many voltage sources are there in mesh 2? You can see there is a 6 volt over here, and as you are scanning through, you can see there is a 9 volt over here. So I can see that if I am starting from the 6 volt, it will be plus 6 minus 9. It's going from plus to minus. So V2 will be plus 6 minus 9, and here you can see it will be minus 3 volts. So the V2 I can fill over here as minus 3. I hope it is clear. So you have I1, I2 and you have V1, V2. V1 and V2 we have filled it out. I1, I2 are the values that you need to find out. Next we are going to fill the matrix, that is the resistance matrix. Okay. So for the resistance matrix there is a specialty. You can see the terms R11, R22. Okay. R11 is corresponding to the sum of resistors present in mesh 1. Okay, so what is R11? R11 is the sum of the resistors that is present in the mesh 1. Okay, so how many resistors are there in mesh 1? You can see there is a 1 ohm resistor and there is a 2 ohm resistor. So you simply take the sum of these values. So 1 plus 2. So here I can say R11 is equal to 1 plus 2, that is equal to 3. So here R11 is equal to 3. Okay. So you got R11. Next R22. R22 will simply be the sum of the resistors present in mesh 2. Okay. So R22 is the sum of the resistors present in mesh 2. How many resistors are there? So here you can see R22 is equal to 2 plus 3 plus 4. So that will be equal to 9. So R22 is equal to 9. Right. So the diagonal values R11, R22, you simply take the sum of the resistors present in that corresponding mesh. If it is 1, you take the sum of resistors present in the mesh 1. If it is 2, you take the sum of resistors present in mesh 2. Okay. So I hope that is clear. Now for the off diagonal resistors. For the off diagonal resistors, what you have to do is that you have to, if it is our resistance R12, okay, 1 and 2, okay, so that means you need to check the value of resistors that are common to mesh 1 as well as mesh 2, okay, common to mesh 1 and mesh 2. So you can see over here the 2 ohm resistor is common to the meshes 1 and 2. Okay, so here I will write 2 and I will give it a negative sign. Okay, so for the off diagonal elements you have to give a negative sign. Similarly, you look at R21. R21 is again, it is meaning the resistors that are common to mesh 2 as well as mesh 1. So here you can see the resistor common to mesh 2 and mesh 1 is again only the 2 ohm. So again I will write a 2, and since it is an off diagonal matrix, I will give it a negative sign. And now we can simply solve this particular equation using the Cramer's rule. Okay, some of you might have heard about the Cramer's rule. I'm not sure about that. Anyways, we can study about the Cramer's rule for those who don't know it. Okay, so the Cramer's rule is simply a rule that is used to solve matrix equations. Okay, so you can see how we are going to study the Cramer's rule. So for the Cramer's rule, suppose I want to find out the current I1. Okay, I want to find out the current I1. I1 will be equal to delta 1 divided by delta. I1 is going to be equal to delta 1 divided by delta. Now what is delta 1 and what is delta? Okay, so delta, we can just see what is delta. Delta is simply the determinant of this particular matrix. Okay, so that means delta is the determinant of 3, minus 2 and 9. And what will be the determinant of this matrix? 3 into 9 minus 2 into minus 2. And the value will be 23. There is a calculation mistake, please forgive me, and I am guessing the value is 23. Now, that is the value of delta. Okay, so the value of delta is simply the determinant of this particular matrix. So, what will be delta 1? Okay, so you want to find out I1, right? I1 is the first element. So what I am going to do to find out delta 1 is that since I1 is the first element, I will replace the first column with this column matrix. the remaining columns will not be changed. Okay, so to find out delta 1, I will keep the second column, or I will change the first column. The remaining columns will not be changed. So the remaining columns are -2 and 9. That is not going to be changed. And the first column is going to be replaced with this column matrix. So the values of the column matrix are 1 and -3. And you take the determinant of this matrix, you will get 1 into 9 minus 2 into -3. You will get the value as 3. And so what will be your I1? I1 is simply equal to 3 divided by 23. That will give you the value of I1. So 3 divided by 23 will give you 0.13 amperes. So you have found out the first mesh current I1. Now how to find out I2? I2 will simply be delta 2 divided by delta. So the value of delta you have already found out. How can you find out delta 2? To find out I1, you had replaced the first column with this column matrix. So to find out I2, what will you do? You will replace the second column with this particular column matrix. The remaining columns will not be changed. So the remaining columns are 3 and -2. That is not going to be changed. You will replace the second column with the column matrix, that is 1 and -3. So you have 3 into -3 minus of 1 into -2. So you will get the value as -7. And how can you find out I2? I2 is delta 2 divided by delta. So that is -7 divided by 23. You will get the value as negative 0.304 amperes. Okay. So this is a very easy method to find out the mesh current. You have to simply write down the mesh matrix equation. Then you can use Cramer's rule and find out the values. Okay. And what have they asked in the problem? You have to find out the current drawn from the source. So the current drawn from the source, the problem is incomplete from the 7 volt source. You have to find the current drawn from the 7 volt source. So the current drawn from the 7 volt source, obviously you can see the 7 volt is present in mesh 1. So the current flowing through the 7 volt is same as I1, that is equal to 0.13 ampere. So we have solved the problem. Okay, so I hope this video is clear, and I will just give you another homework over here. You can see this is another problem. You have to calculate the current drawn from the source. So I'll just help you in writing down the matrix equation. Okay, so here again you can see how many meshes are there. There are 3 meshes, I1, I2 and finally I3. So you can see, since there are 3 meshes over here, our matrix will be larger accordingly. You can see in the previous problem there were only 2 meshes. Therefore, here the resistance matrix was 2 by 2. Here, since there are 3 meshes, the matrix will be a 3 by 3 matrix. Okay, and the values will be R11, R12, R12, R13. R21, R22, R23, R31, R32, R33. Okay, and here you have the column matrix, that is the current column matrix I1, I2 and I3. This will be equal to a voltage matrix. The R into I is equal to V. V1, V2 and V3. How can you find out the value of V1? You look at the algebraic sum of voltages present in the mesh 1. So in mesh 1 there is only one voltage source, that is 60, and you can look at the direction, it is going from minus to plus, so V1 is 60. So here you have V1 is equal to 60. Your column matrix I1, I2, I3 will not be changed, you don't know the values, and here you have 60. Then you can see in the second mesh there are no voltage sources, so it will be 0. In the third mesh there are no voltage sources, so that will also be 0. And how to fill out the resistance matrix? As I mentioned before, 1, 1, 2, 2, 3, 3. These are the diagonal matrices, right? 1, 1, 2, 2 and 3, 3. These are the diagonal matrices. So the diagonal matrices will always be positive. The diagonal matrices will always be positive, and if you want to find out 1, 1, you simply take the sum of resistors present in the first mesh. So 1, 1 will be equal to R11 will be equal to 7 plus 12, and that will be 19. What about R22? R22 will be equal to sum of resistors present in mesh 2. So that will be 12 plus 6, and that will be R22 will be 18. Then R33. R33 will be the sum of resistors present in mesh 3. So that will be 6 plus 12. So again that is going to be 18. Okay. So the diagonal matrices, they will always be positive. Next we are going to take the off diagonal elements. Next you are going to take the off diagonal elements. So the off diagonal elements, they will be negative. Off diagonal elements will be negative, and R12 is simply meaning the resistance that is common to the meshes 1 and 2. Okay, the resistance that is common to the meshes 1 and 2. So R12, you can see the resistance common to the mesh 1 and 2 is 12 ohms. So that will be minus 12. So if you get R12, that will be same as R21. So here also you have minus 12. Then R13 is the resistance common to the mesh 1 and 3, that is 6 ohm. So here it will be minus 6. So R13 and R31 will be the same, right? So here also you have minus 6. Then not minus 6, R13 is, my mistake. R13 is the resistance common to mesh 1 and mesh 3. So you can see for mesh 1 and mesh 3, there are no common resistors. There are no common resistors between 1 and 3. I'm really sorry. That was my mistake. For meshes 1 and 3, there are no common resistors, so the value is 0. Then for R23, you can see the resistor that is common to second mesh and third mesh. The resistance common to second mesh and third mesh is 6 ohm. So here you can give it as minus 6. And then you can just complete the problem using Cramer's rule. You just find out the determinant in your calculator so you don't make any mistakes. Okay, and you find out the value of I1, I2 and I3, and finally you can get the current drawn from the source. Okay. So actually in this particular problem you don't have to find out I1, I2, I3 because the current drawn from the source means the current drawn by the 60 volt. Current drawn by 60 volt is simply meaning I1. So here you simply need to find out I1. You need not find I1, I2, I3. But as a practice session you can find out all the three values. In reality you only need to find out I1. Okay, so I hope this video was useful. If you are having any doubts, you can always contact me or you can comment in the comment section given below. Thank you.